Are we starting?
Yes, Osama, whenever you want.
Okay. All right. Let me start by welcoming everyone to our second Distinguished Lecturer series in the Experiential AI series of Distinguished Lectures. And today we are, just a quick reminder here, I'll do the introductions. And I want to remind everyone that this is our last seminar or talk, lecture in this summer. We will break for July and August, and we will resume with our next lecture in the series in September as planned. And so stay tuned for future announcements. I'll do the introduction of today's speaker, and Ricardo will moderate the question and answer session at the end. So it's my great pleasure to introduce David Lewis, someone I knew from the days when I was back at Microsoft and he was at AT&T, and we were trying to convince him to join us at Microsoft. I think this is the first time I really see him since the late 90s. But he's been up to a lot of stuff very recently. Most recently, he is the Executive Vice President for AI Research Development and Ethics at Reveal, which acquired his prior company, BrainSpace, where he was Chief Data Scientist. Before that, he ran his own consulting firm and was a very influential figure both in the worlds of applied information retrieval and in kind of especially in the legal discovery space. When I met him, he was actually at AT&T Labs or AT&T Research at the time. He got his Ph.D. At the University of Massachusetts Amherst, and before that, his degrees from Michigan State University. So with that, he's going to be talking to us about a very interesting topic: what's happening in the last 20 years. Especially in the area of eDiscovery, which is a very hot and growing area. So with that, I'll turn it over to David.
Well, thank you, Osama, and it is very good to see you. It's been too long. Clearly, I'm going to the wrong conferences if I'm not running into you. So yes, I'm going to talk about eDiscovery, electronic discovery. The way that gets spelled with the capital D in the middle is not my choice. That's the way the industry has gone. I will, whoops, get the slide to advance here. Okay, so I'll talk a little about what eDiscovery is. I will talk about technology-assisted review, which is a human-centered AI approach to eDiscovery. And I'll talk about the technology, the workflow, some of the evaluation issues, and then sort of talk transition into talking about the social system that eDiscovery is embedded in. And then the second part of the talk, so the first part of the talk is, a lot of it is a sort of talk I give many times about what's the technology and how people do it. Second part of the talk is I really want to sort of try to look at the things that we argue about in eDiscovery or have argued about and settled in eDiscovery, and try to take a bit of a amateur historian approach to sort of why things have come out the way they are or why they haven't been settled, and sort of look at really how AI is within a human context, not just at the level of, say, a person teaching a machine, which is how we often think about it, but the much larger social system that leads us to use these technologies in a particular way in the law. I think there's a Q&A box, so feel free to pop in with questions if you have them along the way. One thing I want to stress is I will be talking about the law a lot, and actually a little more in this talk than I usually do, talking about case law. I am not an attorney, which means I am completely unqualified to be talking about the case law. And so you should take everything that I say about the law with a very, very large grain of salt. It's, sort of what I've overheard from people who actually know what they're doing. Okay, so what is technology-assisted review? It's essentially AI-supported workflows for reviewing large collections of documents, where you have to somehow find the good documents, typically a small number among a large number of uninteresting ones. And I want to distinguish it from ad hoc search, the sort of thing you might do with Google or even on a case law search system. It's an industrial process, right? It involves millions of documents potentially. It involves potentially teams of dozens of people reviewing documents. Supervised learning plays a large role. And it's also not sort of like many text classification applications. And I say that probably in two ways. One, most text classification is generalization oriented, so that you are training a model to use on future data. Like, so you're training on today's newswire stories to attach labels to tomorrow's newswire stories. In TAR context, you typically have all the data up front. I mean, it may come in bursts, but at some point you have all the data you care about for a particular project. And that actually affects a number of things in the way that machine learning is used. And the other is that full automation is simply not tenable here, that there are subtle legal decisions to be made in deciding whether a document's relevant. Often there may be in other applications, medical decisions to be made. So one is inevitably in a kind of human AI process with these applications. eDiscovery is the one I'm going to focus on, that both includes civil litigation, also things like regulatory review, sunshine law requests, things like that. The discovery portion, and here discovery refers to a particular part of a legal case. It's sort of gathering the facts that are necessary for the legal case. And that is a particularly extensive and intrusive process under the legal system in the United States. You can sue somebody and then ask to see hundreds of thousands of their email messages internally. And if the judge says, yeah, you got a good lawsuit there, you get to see them. But there are many other applications for technology-assisted review. Systematic review in medicine is one where you really find like every single clinical trial of a particular drug. Corpus annotation in natural language processing is very similar. Content moderation applications that are emerging in social media are beginning to use this technology. And then there's always been kind of high recall tasks, patent search, things like that. So there's a wide range of applications. I'm going to focus particularly on the legal ones in this talk. So the example I like to give of the prominence of eDiscovery is that both US presidential candidates in 2016 were involved in eDiscovery controversies. Future President Trump was accused of having destroyed email evidence in a lawsuit. This was a kind of common bad behavior in lawsuits that tends not to go well. And then obviously we all know about the Hillary Clinton emails and whatnot. There were some very strange things that were said by the FBI about the Hillary Clinton emails that made everybody at eDiscovery kind of laugh. They said, oh, it's going to take, 200 years to go through these emails or something like, we all had, products that would let you do it in 2 days, right? So anyway, it achieves a certain prominence in the news occasionally. So there's basically kind of two things you're going after in technology-assisted review. You're trying to minimize cost, but then you could minimize cost by doing nothing. So you obviously have some sort of effectiveness target. Maybe you have a target on recall, what proportion of the good stuff you need to find. And so both those things, are constantly in tension in technology-assisted review. So there's been all sorts of studies, basically starting around the late 1990s. There began to be substantial worries about the cost of the discovery process, and the ball, at one point there was a belief that, well, we're going to get rid of all this paper and we'll have electronic documents and everything will be easier. What that just meant was that people could create a lot more documents. And there were some changes to the law that said you really had to deal with this stuff. And so people began writing, fancy reports about it. But, the bottom line was it all comes down to manual review. You're paying people who are attorneys, typically in eDiscovery context, to look at documents. You may have millions of documents to look at. You just can't afford to have people put eyes on all of them. So this led to, a lot of technological interest. And I'll talk a little about sort of the history of TAR technology. People have been using sort of keyword filters, Boolean queries on hand keyed abstracts back to the 1980s. So there's a long history of IR in eDiscovery, in the discovery world. It wasn't even called eDiscovery then. Probably people date the eDiscovery era to when you started to scan paper. And that for a decade or so was the big technology. Like, you instead of sort of paging through bankers' boxes of paper, you would sort of page through scanned documents on the screen. And, like a big technological advance when was somebody figured out that if you scanned on both sides, but a lot of the pages were blank, like you could remove the white pages automatically and speed up that. So it was the first application of summarization. But then through the 90s, you begin to have documents that were increasingly originally electronic in their creation. A lot of attorneys just sort of tried to ignore that. They said, we're not going to deal with this email stuff. It's not really a corporate record. And then in 2006, there was in the United States a change to the federal rules of civil procedure, which basically said, yeah, you really have to deal with this email stuff. And all of a sudden, you had the prospect of millions and millions of emails that would have to be gone through, even in a kind of modest sized legal case. And so that sparked then a huge amount of interest in various technical methods and even some interest in the academic community. Interestingly, the early kind of period, 2005, 2010, was very focused on improving querying. So people thought of, okay, if Boolean keyword queries aren't good enough, we'll use something else. And so there was a lot of emphasis on what got called concept search. It was never terribly well defined. It was usually some mixture of query formulation, thesauri, LSI, ranked retrieval. But pretty quickly, as people from the academic community got involved, particularly through the legal track, which was a yearly evaluation the National Institute of Standards runs, and you began to have people that had experience with supervised learning, and pretty quickly it became apparent, yeah, supervised learning is the way we want to handle this. It's essentially a text classification task. We already have people labeling training examples. This document should be produced. This document doesn't get produced. Very obvious that that's the way to do it. And then additionally, then active learning quickly became a focus, which is like, okay, if we're paying somebody a lot of money to label training examples, let's make sure we pick the right ones. So that's kind of like the very quick, history of how the field has evolved. But sort of getting into the sort of human AI issues, the core technology is iterative active learning of text classifiers. So you've got, as I mentioned, you've got somebody labeling documents. It gets used to train a predictive model. That predictive model gets used to select more documents to show to the person. Maybe you show them the top ranked documents in the sense you want to get to the good stuff as quickly as possible. Maybe you show them documents the classifier is uncertain about to try to improve the classifier faster. But in either case, you've got this kind of iterative active learning workflow, which people typically diagram in this kind of cyclical fashion. I want to talk a little bit about kind of a little bit different way to do it, which emphasizes the transductive nature here. Because in a generalization framework, you might be training a classifier to use on future data. Here, you're training a classifier to use on data that's right in front of you. So what you actually can think of is sort of a sequence of, I've labeled some data, I train a predictive model, I use that to choose some more data to label, I label that data, I train a predictive model and iterate that process. And as I'm iterating, I have an increasingly labeled data set because I'm working with a finite data set that I have in front of me. So that makes it a transductive task rather than a generalization task. And that mostly affects evaluation. It has a little bit of effect on the design of the learning algorithms. So of course, the question is then when are you done, right? So the whole point of applying these technologies is that you're not going to review every document. And so you've got this decision at each point potentially, okay, have I labeled enough information? If I found enough of the good documents is the way it's often cast. So if you maybe even use a statistical sample and estimate your recall, what proportion of the relevant documents you found, or you may have more heuristic tests. But in any case, this sort of, basically this workflow is going to end at some point. And if we think of the workflow that way, it would be, what I would refer to as a one-phase workflow. And it's very, essentially, you just keep this active learning going until you found enough good stuff. And this is a very traditional workflow in information retrieval. Dates back to the 1960s in relevance feedback in interactive retrieval, which is like arguably kind of the first application of active learning to text data. And it got rediscovered. Interestingly, it got rediscovered second in eDiscovery, and I'll say what got rediscovered first. So it gets called TAR 2. It gets called TAR 2.0 because it was discovered second, even though it's actually an older technology historically. And it's actually gotten a whole bunch of buzzwords associated with it. And there's a lot of debates over one-phase workflows versus two-phase workflows. So I'll show you a two-phase workflow now. So the alternative in a active learning workflow would be to treat it a little more like a generalization task, which is like, okay, I iteratively am training predictive models, but at some point I decide it's good enough. And I say, okay, I'm going to stop this iteration. I'm going to use the final predictive model I've trained. I'm going to use it to identify a large amount of documents. And maybe that goes to a whole big review team. So maybe I am one expert lawyer who's been training this classifier, and I've got my classifier good enough, and now I'm going to prioritize, the top 10% of the collection or enough to hit 80% recall or whatever, and send that to a team of contract reviewers to sort of be done. And now we're done with the training, and I can go back to doing my lawyer stuff, and the contract reviewers kind of review this large mass of documents. And so this would be referred to as a two-phase workflow. This actually emerged first in eDiscovery. It's kind of much more similar to active learning workflows for training text classifiers. Interestingly, and we'll get into the kind of the social aspect here, a particular company in eDiscovery and a couple of thought leaders decided that they didn't like two-phase workflows, and there's a bunch of reasons for that. And because there are some problems in particular with the fact that one tends to use sample-based effectiveness evaluations, which involve looking at large random samples, which are expensive and mostly consist of junk. So there was pushback against these two-phase workflows. There was a very successful kind of marketing campaign to call them kind of a backwards TAR 1.0. And this TAR 1.0 versus TAR 2.0 fight goes on to the current day. I'm not going to mostly sort of talk about sort of research results here, but I am going to just throw out a little bit of a comment on that. So one thing to point out is that lawyers' salaries vary substantially. So some lawyers go to prestigious law firms and they start at $200K a year and they go to the moon after that. And some things didn't go so well after law school, and they're getting hired for not much more than fast food wages to, look at documents 12 hours a day. So the notion that if you're trying to save cost, it all becomes really important whose cost we're talking about. And if your phase one review of labeling documents is at $500 an hour, or and that maybe gets you $5 a document per label. Maybe you're paying $5 a label, and maybe during a phase two that involves contract reviewers, maybe you're paying 25 cents a label. You've got a really strong motivation not to let phase one go on too long. And so I did some work with Eugene Yang and Ofer Frieder at Georgetown, sort of studying this, and showed that, if you have, cost structures that where a second phase review is substantially cheaper on a per document basis than a first phase review, you definitely want, not surprisingly, you want to do a two-phase review, and you want to stop the first phase very, very quickly as soon as you've got a decent classifier. So that's kind of the one kind of self-promotional research result we got here. Okay, I'm going to say a little bit about evaluation, which is kind of a, my favorite topic, but I'm going to keep away from all the confidence intervals and things, and instead just say a little bit about the implications for human review. So the effectiveness measure that gets talked about the most in eDiscovery is recall. And this is exactly the measure you may have heard about in machine learning or information retrieval. And it's simply the proportion of the relevant documents which a system has found. That might be a one-phase review, a two-phase review. It might be a classifier that's used at a particular point during a review. And you could evaluate all those things by recall. The interesting thing, and this doesn't get talked about in information retrieval or machine learning very much, is that if you want to make a sample-based estimate of recall, only the relevant documents, only the positive examples are useful. So for instance, it takes 385 relevant documents to estimate recall with a 5% margin of error and 95% confidence. It's an infamous number in eDiscovery. If you have only 10% of the documents in the collection are relevant, you expect to have to take a sample that's about 3,850 documents. If you have 1% of the documents are relevant, you expect to take a sample that's about 38,000, 40,000 documents, right? Almost all of which are junk. And you typically are labeling this, typically have, if you have multiple tiers of eliteness in your attorneys, you typically have the kind of more elite attorney labeling your sample for evaluation purposes, unsurprisingly. And they're very expensive, and they hate looking at relevant documents because it's wasting their time. And so this actually had a lot to do with the emergence of one-phase workflows, which came along typically with kind of more heuristic approaches to evaluation, because people just really hated labeling large random samples for evaluation purposes. And it's a very just social thing. I mean, it's partly the cost, but it's partly that the attorney feels like they are pointlessly wasting their time labeling negative examples, and the attorneys are running the show. And so, there was a strong backlash against this. It led to actually the use of an effectiveness measure in eDiscovery, which is very rare. There's something that's similar in epidemiological research, but it's basically called illusion. And illusion is, if you think of it as, if you think of precision is the proportion of good stuff, say, that made it through a classifier. Illusion is of the stuff that didn't make it through the classifier, what proportion is good. So it's kind of it's the prevalence within the ignored documents of good stuff. And so you want it to be low. You want to say, okay, I have, the stuff I'm not looking at, say that my TAR procedure is rejecting, proportionally, there's very little relevant material. It's a pretty weird measure because you could, your original collection might have had a very low proportion of relevant material. It doesn't mean machine learning can't find the good stuff. So it's interesting. It's a rather odd measure, plays an odd role in eDiscovery, and its existence at all is very much driven by the social phenomenon that, largely that attorneys don't like looking at negative examples. Okay, so that's just a little bit about effectiveness measures. I want to say a bit about the players in eDiscovery. So who's involved in eDiscovery? Well, at the top of the food chain, in some sense, there are legislators who pass laws. It's very rare that laws get passed directly about, or well, put it this way, Congress critters aren't very interested in the mechanics of the discovery process in the law. What you have, is they say committees of judges who talk about these things and make recommendations, every some number of years, which, Congress will sort of more or less rubber stamp. That's, say, federal rules of civil procedure. Judges then are, the next most kind of prominent people in this process. If you go to a kind of legal trade show or a legal conference, it is quite startling, say, as a computer scientist going in, a scientist, coming from a relatively egalitarian culture, to see the startling deference that judges are paid, even in kind of social situations by attorneys. So they're the ones who call the shots, right? At the end of the day, if things come to legal conflicts, there's some judge, who's going to make the decision on them. Attorneys are then actually, so I would say attorneys then are kind of the next down the food chain, but of course the attorneys are paid by the clients. So I really should have put the clients in here as calling the shots too. Then there's legal service providers. These are companies to which you outsource legal matters that, maybe are more technical or more routine. So for instance, they may do the collection of data from everybody's file shares in a case and image people's cell phones and things like that. But they may also manage review teams of attorneys themselves if the law firm doesn't want to be in that business. And there's a lot of back and forth about, what aspects of this get handled by law firms and what get handled by legal service providers, what get handled by lit support people within a law firm. Then there's technology companies who sell software that legal service providers or law firms use. And then there are academic researchers, and eDiscovery has not been terribly prominent in the scientific community, but it has gotten a little bit of attention. There's a modest literature on it. Okay, so I'd kind of skipped ahead to this slide accidentally. So one of the things I want to talk about is that all these people produce documents, right? So legislators and regulators, they have laws and rules. Judges issue decisions. They also are part of the intellectual culture of the law. They may write law review articles, but some of them also do less formal articles and trade publications. They give interviews, they give speeches. Attorneys file motions in court, but they may write white papers. They may write blog posts, law review articles. The more technical support folks tend to be, they're writing white papers, reports, affidavits. They may appear as an expert witness in court. And then, scientists write blog posts, and sometimes they still write scientific articles. And they may appear as experts in court as well and fill out affidavits. And so I guess the interesting point here is that everybody is churning out documents, and many arguments about human-centered AI, many of the debates that have happened in the law have happened in public. And for AI, eDiscovery has a relatively long history, but it's also all within the social media, if you count blogs, era. So the debates here, or many public debates, between thought leaders, people posting wild blog posts, as well as court fights that led to public records. There's continuing legal, like lawyers have to do continuing legal education, which means they have to go to a certain number of classes each year. Those classes have to be signed off by a state bar association. That bar association requires written materials have been associated with the class. So there's a documentation of what was said in these classes. And so there is really a remarkable paper trail. There's a long history of fighting about and working toward what the vision of human-centered AI would be in the law. And it is extraordinarily well documented. So I think there's a great deal to learn about how moving human AI processes into an industry plays out. And I think there's probably a lot to learn for other fields here. I actually got interviewed by a historian a couple of weeks ago who was exactly looking into this, kind of one slice of the early history of TAR. So anyway, I think it's just this is kind of my plug for people who are interested in human-centered AI to kind of look at eDiscovery as a place that there's a lot to learn from. Okay, so for the second part of the talk, what I want to do is look at some of the debates that have unfolded over the past couple of decades. Because if you go talk to somebody who works in eDiscovery now, they'll have a pretty clear sense of at least a more or less standard way. There's debates, but a more or less standard way to go about using AI technology in eDiscovery. But it was not at all clear early on how that was going to play out. It was not clear how it was going to play out technically. So I mentioned there'd been a lot of interest in, maybe it was all going to be about query reformulation. And no, it turned out to be about supervised learning. But then even within supervised learning, there was a lot of unclarity about the workflows, who was going to do what, who was going to have what responsibilities, what was going to be allowed, what was not going to be allowed. And so I want to talk about how some of those things played out in the law and play my amateur social science historian role about, what can we learn about the evolution of AI human teaming, and what might we expect from other fields there. So the first controversy, was kind of like, is this okay to use this technology at all, right? And to focus on that question, can you use supervised learning on a modest amount of data to train a classifier and use that to identify the portion of the documents that are going to get human review and the portion that you're going to throw out without a lawyer ever looking at them? And so the way I'm kind of going to frame these debates is sort of try to almost like factors in a legal analysis, which again, I am not a lawyer, and sort of say, what were some of the arguments kind of for and against this, and how did it play out? So, probably the strongest argument was people had already been doing keyword culling for a couple of decades. And we know from the scientific literature that trained classifiers were substantially better than keyword classifiers that people build by hand, particularly if they don't iterate on the data. For the most part, an expert searcher can do very well. Keywords are also very awkward to tune, so it would be like common, and the context in which you tune them then was very was difficult, in the sense that you would have two parties in a legal case negotiating over what keywords to use. But the producing party in the case was the only one that could see the documents. So the party that's requesting documents, they're not being allowed to see the documents. So they're kind of guessing out of thin air what keywords are going to be useful and proposing them to the other side. Typically, the only thing the other side would give them back is a hit report that said how many documents did the word hit on. And then they would complain that certain keywords hit on too many documents, say. So it was a very awkward process, and I should say, keywords are still used. And it is an awkward process. So another factor here is that attorneys are generally given great discretion over the production process. I mean, they've got to sign off on the process, so they're given great discretion. And that was kind of a positive and negative factor here. If they have discretion potentially to use machine learning. On the other hand, they've got to sign off now on saying that they are asserting that they know everything's okay with this machine learning process, and he used active learning and logistic regression and a bunch of things that lawyers went to law school because they didn't want to learn about. And so, there was a little bit of, question there about how, comfortable attorneys would be signing off on that, and whether they were even qualified to sign off on it. Right. So one of the things that's emerged over the past couple of decades is this kind of duty of competence that has been updated in the bar associations for many states to say that if a lawyer signs off saying that technology worked okay, they actually had to understand that the technology worked okay, either personally or they had to hire appropriate experts. So this was kind of dicey. But I think probably the biggest argument against was there was an argument being made that, you're turning a decision that was usually made by an attorney over to an AI system. Now, people had already become very comfortable turning decisions usually made by an attorney over to a bad keyword query, but nevertheless, somehow AI machine learning was felt to be different there, right? So as you can probably guess, since I'm giving this talk, you can probably guess the way that this has come out is that, yeah, people can use machine learning. It's broadly accepted. As I said, it wasn't obvious it would come out this way, and it's the process by which it became broadly accepted was a very complicated social process. If you want to put a timestamp on something, you'd say the first U.S. Federal court approval of a protocol that used supervised learning was in 2012. But there were already plenty of cases where producing parties were using supervised learning before that, and sometimes telling people and sometimes not, that they were using it. And a bunch of actions outside the legal system had huge influence. The TREC legal track, which was this yearly evaluation that the National Institutes of Standards ran, was incredibly influential. Some of the people who were organizing it gave a lot. So Jason Barrett, Doug Ord, and I organized the first one. A number of other people came in later. All of us were out giving lots of talks about it. There was a very famous attorney, Jason Barron, who was ubiquitous. Pretty much every day he was out somewhere in the world talking about machine learning and IR, and AI, and whatnot. You also got, you had lawyers writing scientific publications. You had scientists co-authoring law review articles. So there was a huge amount of cross-fertilization. There was incredible amount of activity in sort of blog posts, attorneys who would write about this stuff both as an educational way, but to try to attract people to their law practice. There were trade shows and marketing. There were court fights and expert testimony. And so it was, very complicated process that got us to 2012 then and beyond. But I think at the end of the day, my personal opinion would be the major factor is just that courts show extraordinary deference to the attorneys for producing parties, and particularly on technical matters. That is, if a judge were to say, a judge is kind of going out on a limb if they approve, let's say a receiving party challenges some technical approach that the producing parties used. Well, so now the judge is in a bit of a pickle because, either they need to bring in expert testimony, affidavits and whatnot, and then they've got to weigh those, which they typically, it's not, these are not patent judges, right? These are not people who these are judges who mostly are magistrate judges who spend their time on procedural issues in the law. They're not technology experts for the most part. They're not thrilled with anything that slows down the process. And they certainly aren't going to go out on a limb almost certainly and express their own technical opinion, because then they're, putting themselves in danger of being overruled or something. So I think the general principle one gets out of this was that there were, by the definitive social actor here, who's the judge, had a strong motivation to defer to the producing party's attorneys. And at the end of the day, the producing party attorney is signed off saying it was okay. If the other party wants to challenge it, well, then maybe you have to have a court fight about it. But then it's kind of a higher bar, because the challenging party has to then make some solid argument that something went wrong in the production. And that's very difficult because, of course, they only get to see what they were given. They don't get to see what was thrown away. By definition, they do, the stuff that's thrown away is the stuff that's not produced. So it's actually very hard for a producing party to show that there was a problem with the production. So all of these things, I think contributed then to this complicated process by which it became okay to use machine learning. So let's look at the other way. We have every reason to believe that supervised learning is much, much better than keyword queries. Can you compel somebody to use supervised learning, right? Or in fact, does everybody just use it in 2021, right? We've got clear evidence it's way better. Producing parties are always complaining about the cost of discovery. And they complain this in order to say, all right, I only want to get these 10 people's emails, not these 20 people's emails, because it's going to cost us too much. So the obvious counter response is like, hey, if you think it costs so much, use better technology, right? I think many of us technologists had kind of felt, that's kind of the definitive argument. But then there's a bunch of other factors here which potentially work against this. One is, again, if we're giving a lot of discretion to the attorney, it's not giving him discretion if you're kind of forcing, if the court is forcing him to use particular technology. So now the judge is way out on a limb. Say, I'm sorry, you can't use this technology, you have to use this other technology. That's way, way out on the limb. And, and then they would be forcing the attorney to sign off on something which maybe they don't even understand very well. You still have these other arguments, which is like, well, AI is making, maybe I don't want AI to make these decisions. TAR software and services have non-trivial costs associated with it. I work for a TAR software company, and I can tell you with great assurance that those costs are worthwhile. But there's costs involved. And then, law is kind of risk averse. It's very focused on the sort of the excellence of individual practitioners. Frankly, a lot of people went to law school because they didn't like math and science and computers and stuff. And it's a little sort of phobic of technology and slow to adopt compared to other industries. So, you might sort of think to yourself, well, what do you think the state of TAR is in 2021? What would be your guess about that? And the answer is, well, it's used a lot, but it's kind of used in it's optional. It's certainly not mandatory. The case law, there's been some attempts to force producing parties to use machine learning, and those have gone nowhere. Courts have not been willing to do that. And as I said, you could then claim, well, maybe as a requesting party, you could try to say, well, they blew it, they should use better technology, but it's very hard to prove they blew it. So what we've actually seen is kind of steady increased adoption, but it's been very gradual. It tends to be in the high dollar cases. The bigger the case, the more likely, the bigger the case, you're more likely to have to gather more documents, which means you're more likely to want to reduce your costs with better technology. But it also depends on the enthusiasm of individual attorneys, the type of legal matters. However, even with this gradual adoption, there's been a huge growth, and it's a many billion-dollar industry now in eDiscovery software and services. There was a $2 billion investment in one of our competitors recently. So it is grown to be a big thing. On the flip side, most cases are small. It's a kind of Zipf's law thing. And in the vast majority of cases, and even the vast majority of attorneys, have nothing to do with AI, right? I think one of the things that's been interesting is that it has emerged in the law to have eDiscovery as a specialty, right? So it used to be people kind of stumbled into eDiscovery. It was maybe not kind of a high profile, prestigious thing, but now there's people who really, there's elite attorneys who specialize in eDiscovery issues. They're very knowledgeable about the technology, about AI, about evaluation. And so it is, and that then leads to more comfort with using the technology then. So there's this iterative process of, as the technology gets used, you develop people who have that specialty. As you develop people who have that specialty, the technology gets used more. All right, well, so here's another one. Keywords have been used for a long time. Can you use both, right? Can you filter on keywords and then take that filter down collection and use supervised learning to filter it down even more? And if you're a technologist, you're probably cringing if you see that. Here we're going to take a terrible classifier, right? And we're going to potentially lose a large amount of relevant material. And then we're going to take only what's left and put it into machine learning, which could do a much better job than the keywords had done. And to say, just how bad could this be? This is like the one communications of the ACM paper that everybody in eDiscovery knows about. And it basically, it was a very early study, and this was keyword querying on key punched abstracts of paper documents. So the average keyword query in this case had 20% recall. The attorneys believed they had 75% recall. They, in fact, signed off. They certified that they had 75% or better recall. And so, there is substantial reason to be skeptical of keyword queries. And this is particularly keyword queries in this blind man's bluff kind of situation where you've got, one party suggesting keywords and without being able to try them out. So what's we got? The strong argument here that, you take a low recall classifier, you chain it with a high recall classifier, you're going to get a worse recall classifier. We know that trained classifiers are better. We know there's better, if you've got domain knowledge keywords, there's better ways to use it than keyword queries. But then there's the factors in favor. So there's this negotiation process. This negotiation process is expensive. That might be a plus or a minus. It's expensive, but the money's going to lawyers and the lawyers are making the decisions, so they're not necessarily against it. It also gives this illusion of control. I think there's substantial argument that the control is largely illusory, that people do not have a good idea how good their keywords are. But then we've got these things, attorneys have a lot of discretion, there's a lot of case law precedent for using keywords. And then there are some cost pressures, like, to some extent, some pricing structures for TAR software are on a per document basis. So then you've got a cost, maybe if you've got like a cheap keyword search engine and an expensive TAR engine, maybe you use keywords to prune it down. So, what to a technologist would look like a, no way, it looks a little more complicated in the social context. And so again, I'll ask you to kind of predict how this has come out. And there actually have been cases like people have challenged this approach. And basically it's not unusual to see this happen. This what would be viewed as a technically very poor workflow is actually quite common, not ubiquitous by any means. And it seems to have held up to court challenge. And I have to say, the fact patterns in the cases are complex. I am not an attorney, I will stress again, but it kind of seems like, if you want to do this, and you're in a good enough position. I mean, another thing to keep in mind is all these things depend on the relative power of the parties, right? So if you've got a relatively good case, you've got more ability to argue for doing things the way you want to do. Whereas if you've got a weaker case and you've got less money, you've got bad facts, whatever, you may get, not be able to do whatever you want. But I would say there is a general trend, as I emphasized before, certainly against the courts, against second guessing productions on data science grounds. And indeed, you saw in the early days of eDiscovery, say the first, 8-10 years, you saw a lot more, judges, allowing arguments about these things, bringing in experts to testify. I testified in a federal case, talking about recall and precision, supervised learning, things like that. And that's pretty much gone away, right? I think there was a lot of unclarity, just social unclarity. The law is a bunch of words and they're ambiguous. And so when you have new technology, it's not clear how they're going to be applied. And I think there was lawyers and judges kind of feeling out what was going to be, there were discussions, back in, 2008, 2010, that maybe we were going to have a lot of scientific testimony in discovery disputes. And since I was somebody who made a lot of money doing scientific testimony, I thought that was great. But that's not the way history went here. And, I think probably from the standpoint of the efficiency of the legal system, that's probably a good thing. That, there's the legal system already is many procedural impediments to cases moving along. And it's probably just as well we're not fighting about, confidence intervals in discovery proceedings. Okay, here's a whole bunch of questions which, have to do with, okay, producing parties have great discretion. On the other hand, supervised learning means that, if I label a single training document, I may be determining the fate of thousands of other documents. And even with keywords, at least the parties usually have to negotiate that. The requesting party at least has to agree to a keyword filter. Again, no uniform standards there, but it is fairly often discussed between parties. So then if we're not having keyword filtering, just sort of what does the requesting party get, right? I mean, if you think of labeling a training document as analogous to selecting a keyword, you might feel that that's something that's negotiated. Maybe the two parties negotiate over how to label the training data. And that indeed happened in some early cases. You would see some early TAR protocols where the parties agreed, and you had these elaborate procedures where the lawyers would go in and both sit in front of the computer, or some lawyer would first filter out attorney-client privilege material and whatnot. It was very heavyweight. Some of the early protocols were very heavyweight there. Another question is, do they get to see the labeled data, even if they don't get to judge it? And you might say, okay, well, that seems less problematic. But of course, a labeled training set has both positive and negative examples in it. And the negative examples are documents that by definition, the requesting party is not legally, that has no legal right to see. So that then is this real conundrum that part of your training set is by definition material that you have, in fact, have just determined that legally they have no right to see it. So this was something that actually got fought about a lot. Do you negotiate at least the details of training, batch size, number of rounds, or maybe you don't get to negotiate that, but you at least get to see it. And then I'll throw out a crazy idea, which is like, maybe it's like a giant information retrieval machine learning science experiment, and you get to see sample-based estimates of research paper style effectiveness measures and things like that. So that seems like a pretty crazy possibility. And so, again, think about how you think this has come out over time. Well, this is kind of how it came out. The labeled training set, that stuff went by the wayside pretty quickly. And the definitive argument seemed to be that, hey, if I as a producing party just made my legal determination, you have no right to see this, I'm sure not going to show it to you, even if it was a training document. You tend to see sometimes even today some negotiation over some of these other details, batch sizes, number of rounds, not in most cases, but some. Probably a little more often that this is in discovery protocols. So at least it's, I don't get to negotiate that, but at least I get to know what you did. The producing party reports to the court. But the weird thing is that a lot of the infrastructure of scientific research on machine learning has now been imported into the law. And this is perhaps the weirdest and most startling outcome, which is it is not unusual in TAR cases, certainly again, not ubiquitous and certainly not even the majority, but in kind of high stakes cases where people are negotiating over everything, it's not unusual to see sample-based effectiveness estimates, and even like a protocol that says, we're going to train classifiers and we're going to use a cutoff that'll give you 80% recall. And this is pretty weird because I can't tell you how many attorneys have told me they went to law school because they hate math. But, we now have this whole artifact, all these artifacts, sample-based effectiveness, tuning classifier cutoffs, learning curve displays. A lot of this stuff gets looked at in large legal cases. And I think, this is a kind of fascinating social question, but I think it has to do with the notion of like having a single number is very appealing. The notion that, we're going to give you 80% recall plus or minus 5%, is something that everybody can look at, and at least everybody agrees what that means. I mean, it means something relative to subjective human labeling of an evaluation sample. But it has proven to be remarkably compelling to attorneys, these artifacts that were developed in the research community. So just I guess I'll do this other one plug here. Here's part of the interface of BrainSpace, one of the products from the company I work for. And, you know, I mean, this looks like some kind of data science experimental workspace, right? You know, and we've got this is actually showing a slider which lets you adjust the cutoff of a classifier to hit a particular estimated recall target. There's actually a learning curve display. Here we've got statistics about your training data and your rounds of training data and whatnot, and, you know, score distributions and things. I mean, you know, it looks like, you know, it looks like something you would expect would be used in some, you know, high powered, you know, analytics firm. And yet, you know, you've got, you know, attorneys at legal service providers at law firms who kind of use this kind of software every day. Okay, so Ricardo asked me to talk about deep learning, so you got to talk. It's legally obliged if you're giving an AI talk to talk about deep learning now. The AI police will come take you away if you don't. You know, what's the role of deep learning? You know, how do we think about that? Well, we've got pretty solid evidence experimentally now that transducers, you know, will typically improve text classification effectiveness. You know, and you can imagine some other goodies that come along that. We've got like, you know, multilingual BERT, you know, or you potentially can train in one language, classify in another. On the flip side, you know, it still takes a lot of expertise to tune these things. You know, the data in eDiscovery, you know, it's like emails and Word documents, things. It's not exactly like the web data that the transducers are usually trained on. You know, law firms and legal service providers, for the most part, don't have really like heavy duty IT infrastructure. So the computational issues are not trivial. Now you say, well, okay, you put it in the cloud, but, you know, there's legal issues potentially with putting things in the cloud, or at least people are still feeling their way around how they feel about that for legal cases. And then on top of that, you've got, you know, active learning is really crucial. So if you're doing fine tuning with active learning, you know, that's multiplying your computational expense. And then, you know, there's this issue of the kind of bias and ethics. You know, there's a variety of critiques, which I won't go into here, about, you know, what sort of prejudices get incorporated into large scale language models from their data. And so it's, you know, you'd look at these and you'd say, you know, not clear where things would be. And as a matter of fact, it's, you know, it's early days, right? There's a lot of people talking about deep learning and eDiscovery. Some software providers, including my firm, have released some deep learning technology, typically for running in the cloud rather than on premises. But it's very limited compared to the adoption in, you know, say image recognition or speech recognition, where it's kind of just sort of within a very few years took over the whole field. Okay, so that's about it. So I guess the key points I want to leave you with are eDiscovery has a long and unusually well-documented history. So I think there's a lot to learn about human-centered AI from our experiences there. And then, you know, human-centered AI in the law, I look at as not just being like, you know, HCI. It's not just somebody sitting in front of a screen and how you make that work well, and, you know, what active learning algorithm, but the ability to use the technology actually in practice has been affected by a remarkably complicated, you know, interplay of kind of technical and social factors, which kind of has made it an extremely interesting area. So thank you for your attention, and happy to take questions.
Thank you, Dave. I had an interesting learning curve during your talk. So I have learned a few things. While I don't know if we don't have questions in the Q&A, but if someone wants to ask a question, please raise your hand. But in the meantime, I have a question. So there is any study on errors in the labels that lawyers do? Because you're assuming in all the presentation that the labels are correct, but this is not always the case, or there's some ambiguity. I'm sure in legal cases it's hard to have perfect labeling. So any knowledge on that?
Oh, sure. So I mean, there have definitely been studies that show that you get large amounts of disagreement in what's a responsive document, and that's unsurprising. People don't tend to worry about that very much, in the sense that, at least intuitively, the belief is that the disagreements are on marginally relevant documents, and that if you really have a smoking gun important document, everybody's going to agree it's a smoking gun important document. Now, assuming that they don't miss it, right? I mean, you maybe one reviewer spotted that and one reviewer didn't. But the idea would be, the usual assumption is that, if the appropriate material in that document is called to attention, it would be, everyone would agree that it was relevant. I think this does implicitly have a big impact, though, because it does call into question this whole use of, like, recall, for instance. So people use recall because it's impossible. They use recall on sort of everything that's defined to be relevant, because there's too few smoking guns to do any kind of statistical measure, right? You're just inevitably, you can't statistically characterize finding the small number of unique documents. But that means then, when people, if you had two different people labeling the same random sample, one of them might come back that you had 57% recall, and one might come back that you had 89% recall, potentially, not at all impossible. And so it's the place where this has particularly affected, I think, evaluation is in, I mentioned these one-phase workflows, where basically you are just have a human being who's iterating with the machine until they find what they think is most of the relevant documents. And so you don't have a classifier you're going to evaluate. What you're evaluating is the human being. And then you're going to evaluate one human being against another. And that then becomes kind of very dicey. And that actually has led to the use of illusion, where you never actually evaluate the review decisions that got made. You evaluate the documents that got skipped, and you never actually look to see how good your review decisions were.
I see.
Yeah.
So a question from Osama. So what are the open research issues where you think academia can help this eDiscovery industry?
There's a, my favorite issue is kind of the interaction of evaluation and active learning. There's a bunch of unsolved questions in evaluation. So Eugene and I just did a paper on evaluation of, because one of the things that comes up is sequential bias. So you've got, let's say you're doing an iterative workflow and you're deciding after each batch whether to stop. So the fact that you're conditioning your stopping decision on a statistic from a random sample introduces sequential bias into the estimate from the random sample. Mm-hmm. And there's several problems there that have not particularly been solved. I would say, though, that, probably the sexy problem is active learning with transducers, right? So if you're fine tuning transducers, that's already a pretty tricky process. And if you're now doing it in an active learning context, one, it's computationally expensive. Two, it's very unclear. You're now choosing data for some sort of leverage measures or in some uncertainty or something, but there's not a lot of information on sort of how you tune to that. And you've got your transducer was trained on 500 million web documents, and now you have 200 email messages. So there's just a bunch of experimental work to do to both to sort of sort out the tuning issues and to make it fast enough to run on, ideally, hopefully fast enough to run without having to have a closet of GPUs at your legal service provider. So those would be the two. But I could go all day on open problems, but there's a bunch of them. Yeah.
So here we have an interesting question that is related to the last part of your answer from Animish Patak. He asked if it's necessary to add the capability to unlearn past classifications to accommodate new rulings or court decisions. So do we need to forget the part of the past because of the future changes?
That itself doesn't tend to be an issue, because I think it's important to recognize that these classifiers have a very short lifetime, right? So if you're training for responsiveness in a particular legal case, when that case is done, or in fact, even when the discovery portion of that case is done, you don't use that classifier anymore. Now, there are, if you say maybe you're a pharmaceutical company, you could easily have 200 lawsuits on very closely related issues. And there are then the interest in training models, say for a particular topic, which would be reusable across multiple cases. But even there, it's not new legal rulings that are affecting that. It would be a new conception of the case, or it would be some new criteria you've negotiated with opposing parties that would be relevant there. I would say probably actually the more strong effect here is just from the beginning of the project to the end. As you're labeling documents and as the case is progressing, you're learning about the case, and that itself may change your definition of what a relevant document was. And so actually it's not unusual for somebody to sort of do an iterative active learning process, but then maybe go back and double check like the earlier decisions or the ones that disagree with a classifier. We have support for that in our software, where you go back and you double check some of the decisions you made, not because anything in the world changed, but because your conception of the case changed from your own experience.
I see. So we have another question here from Hassan Bashiri. He's asked, based on this fact that eDiscovery process most data are, it says audio, not sure if that's true, we need more NLP and ML than IR and text mining techniques. Do you think that is true? So basically it's more about NLP and machine learning?
Currently audio is a pretty small proportion. You'll occasionally get cases where they've collected voicemail. I suppose you could imagine that maybe as things go forward, you'll have more video that has audio components, but at least right now, audio is not a big issue. If I was sort of bringing up that kind of point, what I would point to is MT. So one of the biggest issues in large cases that involve international firms is you've got data in multiple languages, and you may have, maybe you've got like only, 1,000 documents out of 1,000,000 are in Chinese, but you can't ignore those. I mean, there might be something important there. So there's increasing interest in MT. So for instance, our software, some of our clients, will use send documents to Amazon machine translation and then put them into our software. And MT is not perfect. It's gotten a heck of a lot better the past 10 years. And so that's you can have a very interesting discussion when you've got a multilingual collection about what the most cost-effective and efficient way is to deal with that. Do you break it up? Do you train it together? Do you use MT? And these are things that kind of sophisticated legal service providers, this is kind of their bread and butter, is kind of sorting these issues out.
Another question from John Guerra. It's what role does the user interface play on these active learning systems? Have you seen any interesting advances in this area? Because he's particularly interested in visualizations helping this.
It's a huge issue. I mean, actually, one of the reasons that I went to BrainSpace originally was that they had a real commitment to UI design and trying to design co-design of active learning methods and UI. That said, I would say that it is a underexplored area, particularly in the academic research community. So to the extent to which there's academic research on TAR, it is tended to focus on the machine learning and active learning and statistical evaluation, things like that. There's been very little UI work, and there's fascinating UI questions. I mean, I can just rattle off a few. You've got email threads, right? And there's in different legal circumstances, the entire thread might be considered relevant if it has one message, or it might not. You've got the contextual information. You may have like a 500 message email thread, and you really need to see message 47 and message 53 and message 60 at the same time to really know that this is relevant. You've got a huge amount of issue with duplication and near duplication, where you've got lots of copies of documents that are minor variants of each other. And we could use way better interfaces for letting you kind of manage that in a more effective way and understand when the differences are relevant, when they're not. So I think there's just huge opportunities for better UIs in the area.
That's great. I think that's the answer what John wanted.
Yeah, yeah, right.
So
Oh, good. Yeah.
you got it. So, so I already over time. So, Dave, very interesting talk. I love big pictures, and this was a great big picture.
Oh, great.
And thank you for being here, and hope to see you in person in the near
Yeah, I
future.
know. I wish I was there and doing this in person because I missed that.
Yes.
But soon,
Yes.
soon. All right. Take care, everyone.
Thank
Thanks a
you.
lot.